For our final project, we developed cyberbullying classification. The importance of the project: social networks play an important role in facilitating social interaction. However, these platforms reinforce antisocial behaviors such as cyberbullying, hate speech, and cyber attacks. We believe that cyberbullying is one of the rising problems of the new internet era, and we wanted to see how serious of a problem it is for ourselves. And in our research, we have developed multiple models in order to detect a cyberbullying monitoring system as well as compare the models. How to avoid antisocial behaviors such as cyberbullying, hate speech, and cyber attacks. Machine learning can be used to identify cyberbullying efficiently, developing a cyberbullying classification system. This project can be further developed into an automated system where harassing tweets can be detected automatically and report the flagged tweet. We choose dataset for this project from Kaggle. It's called Cyberbullying Classification. This dataset contains more than 47,000 tweets labeled according to the class of cyberbullying. It has 6 classes. These are gender, religion, age, ethnicity, other, and not cyberbullying. These datasets also balanced. There are some important methods. NLTK is a leading platform for building Python programs to work with human language data. We use NLTK library, and pre-processing is one of the most important part of our project. It is necessary to make the text the cleanest and most suitable for the model. We use tweets. In this part, that create new data from Twitter to pull real-time tweets and make them testable on the model. We create 2 models, CNN and bidirectional LSTM.
We need to pre-process our data in order to use it as input in our models. Removing punctuations from our data was the first step in our pre-processing. After that, we made all text lowercase. We also removed stop words. Stop words are basically a set of commonly used words in any language. The reason why stop words are critical to many applications is that if we remove the words that are very commonly used in a given language, we can focus on the important words instead. Separating words and emojis. Also, the lemmatization process was our next step. First, emojis are separated, then we needed to standardize our words. That's why we use lemmatization. Stemming also can be used instead of lemmatization, but we choose to use lemmatization in our project instead of stemming. Then we encoded our labels and find our vocabulary size. We then decided to drop less frequent words. In our project, we choose less frequent words to be words that are used less than 3 times. We then updated the vocabulary after removing these words. Pre-processing also requires tokenization, sequencing, and padding. Bringing the sequence to the same size using padding was a big part of the pre-processing method. We choose the padding size to be 100. Padding function needs lists of sequences that we created earlier. Max_len has to be tuned. It shows maximum length of all sequences. Since Twitter only allows 280 characters in a tweet, it approximately equals to 40 to 80 words in the English language. Padding also has to be tuned. We use the max_len value for padding as well. After padding, all train and test datasets encoded will be classified into 6 categories.
First model is CNN 1D. We use TensorFlow and Keras for building the CNN model. 1D CNNs are also used on audio and text data since we can also represent the sound and text as a time series data. Our model implemented includes 3 layers. First is the embedding layer, which converts the words to its respective embedding vectors. Adding the embedding layer, which will take in maximum of 100 words as input and provide a 100-dimensional output of those words. Second is the convolutional layer, in which main processing of the model text takes place. Predefined filters roll over the sentence matrix and reduce it into low-dimensional matrix. Then max pooling uses the maximum value from each of a cluster of neurons at the prior layer. We use this layer in between the convolutional layers that reduces the dimensional complexity and still keep the significant information of the convolutionals, flatten those matrices into vectors and adding dense layers. These are accuracy of CNN model.
Our second model is the BI-LSTM model. The BI-LSTM neural network is composed of LSTM units that operate in both directions to incorporate past and future context information. It has demonstrated excellent performance for sequential modeling problems and is widely used for text classification. Unlike the LSTM network, the BI-LSTM network has two parallel layers that propagate in two directions with forward and reverse passes to capture dependencies into contexts. Just like the CNN model, the first layer in the BI-LSTM model is embedding layer, which maps vocabulary words indices to low-dimensional vectors. Just as before, it will take in maximum of 100 words as input and provide a 100-dimensional output of those words. We then created another layer by wrapping the LSTM hidden layer with a bidirectional layer. This will create two copies of the hidden layer, one fit in the input sequences as is, and one on a reverse copy of the input sequences. By default, the output values from these LSTMs will be concatenated. Finally, we add dense layers. These are our results. We used SNS scrape packet in order to test our models with real tweets.
The bidirectional LSTM model and the convolutional neural network for sentence classification produce accurate results and have been also used by others in various natural language processing tasks. Convolutional neural network models use convolutional layers and maximum pooling or max overtime pooling layers to extract higher level features, while BI-LSTM models can capture long-term dependencies between word sequences, hence are better used for the text classification.
With using our models, these were our accuracy and loss values we've acquired.